anytime that you only have an exponential expression on one side of your equation, what you're going to want to do is you're going to try to rewrite first both sides so that they have the same base. So that's what you're kind of checking for. So for A here, we have 4 and 32, but we know that 4 is 2 squared, so that's 2 to the 2x equals 2 to the 5th, and then we know that we can set these equal, so x is just 5/2. All right, here we have 3, 9, and 27, so they all have a base of 3. This is 3 squared over 3 cubed, which is 1 over 3, or more importantly, 3 to the negative 1. So now that these two sides have the same base, we know 2x minus 1 equals negative 1. So therefore, adding 1 to both sides will give you 2x equals 0 and x equals 0. Okay, then we jump to part C. And before we can start trying to rewrite both sides so that they have the same base, we actually need to get the exponential term by itself. So right now, I have twice 3 to the 4x. But 3 to the 4x, that's my base, that's my exponent. So what I need to do is I need to first start by dividing both sides by 2 so that my exponential term is actually isolated. All right? So now we're looking at 3, we're looking at 5/2. They do not share a base. When that happens, what you're going to do is you're going to change it to log form, and then you're going to use properties to solve. So I have log, the base here is 3, the exponent is 4x, and it's log of 5/2. And then to solve for x, I need to divide by 4. Now you do need to be careful here, because the number we're dividing by 4 is log base 3 5/2. We are not dividing 5/2 by 4 because we don't have 5/2 as a number. We have the log of 5/2 as a number, all right? And that number is actually unique to itself. So we're going to be doing two things. We're going to be writing the exact solution. So x equals log base 3 of 5/2 over 4. This is the exact. All right, but what you guys are also going to be doing for exponential equations is you are going to also be giving the decimal approximation. So we have a couple ways that we can type this in. All right, for this one, if you have the newer operating system, what you can do, if you go to alpha y equals, we have numerator divided by denominator. It's that first choice there. And on top, we need this log expression, and you can go to alpha of 2, and then it's number 5. So it's log base 3, and inside the parentheses, our input is 5/2, and then we're dividing it by 4, okay? Now, you'll notice that my calculator is rounding to 3 decimal places. I have it purposely set up that way. So if you go to mode, and you see float, all right, if you set this to 3, it'll round it for you. So if I go to float, what will happen is it'll continue going, and you have to round on your own. So you need to know that this would really be 0.209. Okay, but for our purposes, because I know that we're always rounding to 3 decimal places, I'm going to go ahead and change the mode so that it automatically does that for me. So we get 0.209. 0.209, and this is our approximation. So our approximate answer. All right, so you will be, for all the exponential equations, you're going to get into the habit of finding the exact and finding the approximate. All right, for D, notice I have the base to the exponent. So e to the power of x minus 1 equals 8. This is already the exponential term, so I have no need to divide like I did in C. So for this one, I can go ahead and change forms right away. Now I have log. For this problem, the base is e, and it equals the exponent, x minus 1, of 8. To solve for x, I just need to add 1 to both sides. So I get x equals, well, the log base e is really just the natural log of 8, and then plus 1. Now notice, I did not add the 1 to the 8 because I don't have 8 in this problem. I have the natural log of 8, and the natural log of 8 is a very different number. Natural log of 8 is 2.079, okay? So you do need to be careful because when you're adding 1 to both sides, you're adding it to this log expression, and you have to evaluate that before you add the 1. So here, we just go ahead and add 1, then we get the approximate answer to be 3.079.